Hello again, Machine Shop Math fans. This is the review and lecture that will be dealing with Exam 2. As of this semester, this is not Video 4 and 5. No, this is Video 9, which will have several parts. Hopefully just two, but who knows. So right now we're going to start with 9.1. You can look at the video file and you'll tell, so disregard what the note title says. You're responsible for all the videos in D2L up to this point. So I don't care if there's 100 of them. All right, so let's get started. This deals with powers and roots and formulas and such as that, and using a calculator. And the easiest way to do it, I think, is to just do it. Use the formulas. Now, we had a video on shapes, two-dimensional and three-dimensional shapes. And we had a video on the Cartesian coordinate system. You got that video from Khan Academy on Rene Descartes, which you should have already watched. So if we just take a two-dimensional shape, and this is some kind of rectilinear polygon, right polygon, because it's got right angles to the side. And we don't know if it's a square or a rectangle. We really don't care. We have to define that. Now, if we say that both sides are labeled as S, in other words, side A and side B equal one another, then yeah, okay, it's a square. If not, it's a rectangle. Big deal. So the area of a square, you can find this off your formula sheet, or here it is here. The area is side times side. Now, area is what? 2 dimensions, remember? It's going to be whatever the units are raised to the second power. And since the sides are the same, we're just going to say the area is S squared. S raised to 2. That means S times S. Now, drop down here for a minute. Here we have a three-dimensional rectilinear, right rectilinear polygon. We call this a cube, or it could be a rectangular prism. We don't know if the sides are all equal or not. If they are all equal, if A, B, and C equal one another, then we know that that's a cube. If not, it's a rectilinear prism. So A could be a different dimension than B, and B could be a different dimension from C. But we still have a Y direction, an X direction, and we have a Z direction. That's our third dimension. So we have units times units, that's units squared, times units, that's units 3. Units raised to the third power. So let's say all the sides do equal one another. Then the volume is side times side times side. Units times units times units. That's units cubed. So that's volume is the side cubed, or S raised to the third power. It's 3 dimensions. It's volume. Therefore, the units are in 3 dimensions. And if your answer doesn't have the right units on it, it's wrong. Now, some of your calculators will have X raised to the third, or it'll have a cube root, and it may not, and we'll get to that in a little bit. So, area is always in units squared. Units squared. Volume is always in some units raised to the third power. Units cubed. All right? Cubic feet, cubic inches, cubic yards, cubic millimeters, cubic centimeters, cubic meters, cubic whatever. Okay? All right. Now, let's move on. Here we have a two-dimensional polygon. It looks to be a rectangle. Let's say it is, or let's say it's a right polygon. Let's say the angles are 90 degrees, where A equals B. So we're going to say side A equals side B. That means we just have one side, and we're back to where we were up above. The area is S squared. The area is S squared. area equals S squared. You have two unknowns or two variables. You have the area and you have the side. Therefore, we need two formulas. We need two formulas. The apparent formula, the one we started with, the area equals side raised to the second power, or side squared. And then we want to solve for what if we were given the area and we wanted to know what the side would be. So we algebraically rearrange this. And how do you rearrange this? Well, you want to solve for S, right? We want a formula for S. So we took this formula, A equals S squared. And if we want to undo it, then we have to take area equals S squared. And how do you undo a square? Raising it, well, you take the square root of it. That reverses it. And then what we do on this side of the equal sign, guess what? We have to do over here, right? So, yeah. So this leaves us with this formula here, S equals the square root of the area. Now the area is going to be in units squared, right? Units squared. So when you take the square root of the area and units squared, you end up getting the side, okay? Now if we are given a side or we're given the area, we can solve for the remaining. Say S is 12 inches, then the area is S squared, or 12 squared, which is 144 inches squared. Say we were given the area in the first place. Say it's a square, and the area is 144 inches. Then we take the square root of 144 inches squared, and we end up with what? 12 inches, right? So let's go over to our calculator. And we're going to use the calculator in Windows. I don't particularly like this calculator, but I don't really care. Because that's 12, and here's the square root key, x raised to the second power. We get 144. Now, if I want to undo that, now this is a silly calculator because it says 2 as the square root. We all know you don't need to put a 2 there for a square root. We just assume you're taking the square root, but I guess they're being nice or whatever. So anyhow, so let's hit that, and you end up with 12. So we took the square root of it, okay? Now this particular calculator does not have a cube root key, okay? It does have x raised to the y, so we said 12, put the x, so 12 is x. Now what power do we want to raise it to? Let's raise it to the second power. And hit that key again, and we get 144. All right, we get 144. What if we wanted to take 12 to the cube? So let's take 12 and put it over here in the x. Uh-oh, need to clear this out. I always do this with this calculator. I don't like this calculator. One of these days I'm going to get a real live webcam and you can watch me do my calculator. But anyway, I'll quit complaining. All right, so 12 is in the x. We want to raise it to the third power. Hit it again, and we get 1728. Now that means we have 12 times 12 times 12, right? We have 12 times 12 times 12. We have a cube. Just pretend it's a cube. Use your imagination. We have a cube. Oh my God, it's an ugly cube. That's a cube. So we have 12 times 12 times 12. These are inches. These are all inches. So we have 12 inches times 12 inches. That times that is 144. And then we take the 144 and we multiply it times the third dimension. And that gives us 1728. But that's not the real answer, is it? It's got to be 1728 inches cubed. Now we know what we're talking about. 1,728 cubic inches in, but wait a minute, 12 inches is a foot, right? So that's 1 foot. That's 1 foot. That's 1 foot. So 1 cubic foot is equal 1 feet cubed equals 1728 cubic inches. See how easy that is? Okay. All right. Now let's go back over to our calculator. Okay. So we have here, and if I am not mistaken, we have a function. Make sure when you get into doing degrees, you keep your calculator in degree mode, not radian mode, okay? All right, so this does not have a cube root thing here. Oh my goodness. Oh well. Oh, there's the second key. I hate this calculator. There we go. Now we have a cube, the cube key. It's under the second. So if you're stuck using the Windows calculator, then you hit second. There's the first mode, there's the second mode, and there it is, hidden over here. I knew it was in here someplace. I don't like this calculator. All right, so there, we took the cube root, and we've got, we're back at 12, right? So hit the second key, and we can raise that number, because that's in the X register, to the third power, so it does have that. That's 1728. Go back to second, oh my God, and take the cube root of it, and bingo, we're at 12. Now what about here? Here we have X with the Y over here, the radical, and here we have X raised to Y. Well, I just showed you how that worked. Y is the power, the root that you're going to raise it to, the power you're going to raise it to. X is the number, so let's go back to 12. There's 12, put it in the X key, assuming you clear out everything. Clear everything out. 12, put it in the X. We're going to raise it to the third power. Hit the key again, bingo, there you are. Is 1728. Now we know if we go and want to take the cube root of that, we hit that key and we get 12. Come back to here, put it in the X, clear it out. Get to take 12. Oh my God. All right. Hello, Michael. Clear this out, will you? Just clear it out. All right, there we go. Y and 3 equals that. Okay. Now, what if you didn't have what if you didn't have this key, but you did have the Y raised to the X raised to the Y? Well, with a cube root is 1/3, right? Okay. So hit that key, and that gives you 1728. I put 1728 in as the X. It just told the calculator to put it as X. Now, let's come over here. And let's say we want to take the cube root of that. Here's 3. Well, you hit 1/3. Now hit this key, and you're back at 12, right? So what we did is we put, come back over here, we put, select, what we did is we said we had X, oh my God. Go to the marker. Hey, remember, I'm a professional at this. Okay. We had X raised to the Y. Okay. And if we said that 12 was x, and 3 was y, that gave us 1728. You're going to use the 1728 a lot because you're going to convert unit weights per volume, which would be like 150 pounds a cubic foot. You want to convert that to pounds per cubic inch because your volume's in cubic inch to get weight. And we'll deal more with that right now. But okay, so we know that if it's raised to the 3, the whole number 3, then it's 1728. It's 12 times 12 times 12, right? All right, now, what if we didn't want to hit the shift key and we were going to take the cube root of 1728? Well, then we would put 1728 as our x, put it in as our x. And what about our y? I want to take the cube root, so I'm going to put 1 over 3. And it's the same thing as saying taking the cube root of 1728. So, you saw me do that on the calculator. We put 1728, I'll do it again, 28 in. And for y, I pushed in 3, then I hit the 1 over x key, right, to get the decimal equivalent of 1/3, and then hit this key again. So let's go to the calculator. We'll do it one more time. Let's see if I can do this without screwing it up. How's that? Clear it out. Clear it out. Okay, so let's take 12, and we're going to put it in y, right? Wherever y is here. I'll just use the mouse. Y. We're going to raise it to the 3rd power. Bingo. There it is. Okay. Now, hit that again. I'm going to take 3. I'm going to put the 3 as the x here, 1 over x, right? Hit this key again, and bingo, we get 12. Now, of course, we could have come over here and said, okay, we're going to take the cube root of x since we knew that that was that. So this calculator has the square root and the raised to the 2nd power, and it has x to the 3, and it has the cube root, and it also has, you can find any root you want. Let's take 12, and let's say 12, we want to raise it to the 4th power. Again, we'll clear all this out. So we're going to take 12. We're going to tell the calculator, Jesus Christ. We're going to take 12, and we're going to tell it. Okay, this is insane. Hit X. All right, clear it again. Now we should be able to do this. 12, X. There we go. All right, we're going to raise it to the 4th power. All right, hit it again. All right, now. All right, so 12 times 12 times 12 times 12 is this number here. So now let's come over here to the 2nd, and let's tell it that that's going to be x. 2nd. See, this is why I hate this damn thing. And then we're going to say y is the 4th, and then hit that again, and then you should be back at 12. See what a pain that is? The whole idea is you're using a regular calculator with these buttons already on it, so you can just hit the shift and hit the button. But you get the idea of the roots and the power. So if you're stuck with this calculator, just make sure you clear out every one. Equal sign should clear it, and I say it should clear it. Man, I really don't like this calculator. But right now it's the only one that I can put on the video because I don't have an external webcam like an overhead webcam. Maybe someday. All right. So let's get back over here to our notes. All right. Over here to our notes. All right. Marker's still working. Yeah, it's still working. Okay, good. Okay, that's because we didn't open up another one. So let's erase that. All right, so where were we? Okay. So we were saying this here. So if we have a side 12, then the area is s squared, or 12 squared. That's 144. To undo that, to find the area. So now we have two formulas for a square. Now, we could just have one formula for a rectangle, right? A times B, and if A equals B, it's still going to be 12 times 12 because B is 12 and A is 12. So don't overthink this, okay? All right, here is a rectangular prism. And we don't know if this is a cube or not because we haven't been told yet. We know we have side A, side B, and side C, and we know that we have a Y, we have an X, and we have a Z. Third dimension, yes? Okay, all right. So let's see what the story tells us. Okay, A, B, and C equals S. All right, if A, B, and C didn't equal S, if A, B, and C did not equal each other, then the volume would be A times B times C, or whatever the values were for those, right? Real simple. Again, don't overthink this. So we have two variables for this volume. Volume equals S cubed, or volume equals A times B times C. All right. Now, if A times B times C are different lengths, then we need to know at least 3 of those before we can solve it, right? Okay, but let's just say that this is a cube. So volume equals S raised to the third power. Our units will be in cubic something, cubic inches or cubic foot. We did this. 12 inches times 12 inches cubed is 1728 cubic inches. You need to remember this. Then that's 12 raised to the third power, or it equals 1 cubic foot, right? Because 12 inches is a foot. Okay. Now, if we were given the volume, let's say that we want to make a cube that holds X cubic inches of material, or X cubic feet, and we want to solve for what would be the equal sides. Well, you plug in your volume, you take the cube root of the volume, and you get the side, the theoretical side, length of your side. So say we were given the volume of 1728 cubic inches. All right, and it's a cube. All right, so then S equals the cube root of 1728. I think we beat this to death. Are y'all bored? I know I'm bored. So the side is 12 inches. And y'all thought this was going to be hard. It's not hard. All right, now we went to the calculator already, and we located the X raised to the second power and the the square root of X. And our calculator put a 2 there. I guess they didn't think you were smart enough to know that you don't need to put a 2 if you're taking a square root of something. Generally, that's the way calculators are, but hey, Windows is special. All right, we had the X raised to the third power, and then we had the cube root of that. And then we also had the X raised to the Y, and we saw how we could manipulate that. And then we had and we also had a key under the second. I didn't put it on the notes. Oh well. Yeah, we did. And then we had a key where X took this, and then you could take any power of that, any root of that number. And now remember, if for some reason you were going to take X and raise it to the fourth power, then you got something more than volume. So your answer would be whatever the number is, and your units, as silly as it sounds, would be units raised to the fourth power, which is like another dimension or some silly crap. I don't know. So, but we don't do that, at least not in this simple math. So the most you'll see is the thirds raised to the third power. Okay. All right. So, all right. I think that's probably good enough for the calculator. My advice is you play with your calculator a bunch. Go back through, punch these numbers in, make stuff up, whatever, do whatever. All right, this is a repeat. This is a repeat. Let's take our cube again, or our rectangular prism. All right, we have a side A. Could be an S, could be an X. Could be X because it's on the X-axis. This could be side Z because it's on the Z-axis. And this could be side Y because it's on the Y-axis. You call it anything you want. Mary, Bob, and Sue. All right. So let's say that it's 1 foot or 12 inches. 1 foot or 12 inches, 1 foot or 12 inches, 1 foot or 12 inches. So we just define this as a cube. Again, we're beating a dead horse. Volume is the side cubed because they're all the same, yeah? Now, if they weren't all equal, then it would be A times B times C, and you'd still get units cubed, right? So you find the area of one side, and then you throw the third dimension to it. Making these videos, I'm going to have to remind myself, turn the internet off so that we don't get these pop-up stuff. So the volume is 1 foot cubed, or 1 foot cubed. If 1 foot equals 12 inches, okay. I keep repeating this because it seems like every semester people just can't get their head around this fact. 12 inches is a foot, yes? So 12 times 12 times 12 equals 1 cubic foot. But in inches, it's 1728, and you will need this over and over again. Now, we're going to introduce unit weight per volume. It's a fraction. PSI is a fraction. PSI is a fraction, right? Even though we say it's pounds per square inch, it's pounds per inch squared, yes? It's pounds over an area. That's what PSI stands for. It's a fraction. It's a unit weight per volume. The unit weight, this happens to be in pounds. The volume happens to be in square inches. That's PSI over an area, okay? But if this was concrete, if it was dirt, normal dirt around this area weighs 150 pounds a cubic foot. Concrete weighs about 150 pounds a cubic foot. So we would say, let's say we're talking about concrete, 150 pounds for every foot cubed, or 150 pounds for 1,728 cubic inches, yeah? But since we know that 1,728 cubic inches equals a cubic foot, 1 cubic foot, then we'll just do 150 pounds over a cubic foot for this, all right? So it's the unit weight. How much does it weigh per a given volume? And it could be in cubic feet, cubic inches, cubic centimeters, cubic millimeters. It could be in any unit volume, okay? So let's take normal steel. Rule of thumb for just your normal run-of-the-mill steel is about 489 pounds a cubic foot. Now, this is the weight, and this is the unit volume, okay? This is the weight, and this is the unit volume. Now, what if I wanted my steel to be weighed in pounds per cubic inch? The weight is still on the top. It's going to be pounds over here. But my unit volume is going to change to cubic inches. You're going to go, what? Say what? What you say? Well, it's simple. And most of y'all have already figured this out, I'm sure. Okay. In case you haven't, we started out with 489 pounds per cubic foot, because that's what the steel mill tells you. It weighs 489 pounds a cubic foot. So we want our answer in pounds per cubic inch. So this is so simple. Let the fraction guide you. So doesn't that equal 489 pounds over 1,728 cubic inches? Doesn't that equal that? That was a question. The answer is yes. It's yes twice. That's yes squared. So you take 489 pounds divided by the equivalent of cubic feet in cubic inches, which is 1,728. Do the math. Divide that number by that number, and you get 0.2829861111 pounds for every cubic inch. For every cubic inch. So let's just go to 3 decimal places. So we'll use 0.283 pounds per cubic inch, okay? All right. So, the weight of our cube, okay, all right, so the volume times the unit volume. So we'll take our cube, let's take a cube, and we'll come up with a weight, okay? All right. Now we said that this cubic foot up here, all right? So let's go over here and let's do an example. Let's do an example. You have to select. Delete. We're going to have to hit our marker again. We'll do black. Okay. All right. Let's say that we did we had this block. Let's say it's 12 times 12, and then let's say, I don't know, let's say it's 18 inches. That's a pretty crummy drawing, but that's all right. You get the idea. And we're going to say this is 18. And it's all in inches. So what's our volume? We can do the volume one of two ways. We know that this side's 12 and that's 12. So that's a square. So we could say that the volume is 12 squared times 18. Or we could say the volume is 12 times 12 times 18, yeah? And what's our volume going to be? Well, it's 144, that's 12 squared, right? 144 times 18. So that gives us 2,592. That gives us 2,592 inches cubed. All right. And we want to know how much it weighs. So let's say it's made out of steel. So we know that it's 489 pounds. Cubic foot. We've already decided that if it's 489 pounds a cubic foot, it's 489 divided by 1728. Well, that's an ugly 8. It equals 0.283 pounds per cubic inch. All right. That's our unit weight per volume in cubic inches. So all we got to do is multiply this times our volume times 259 to 2,592 inches cubed over 1, because here we have pounds per inch cubed, right? So what do we get? When you multiply this out, you get 0.283 pounds times 259 2.0 inches cubed divided by inches cubed, right? Because in multiplying fractions, you multiply the bottoms and you multiply the tops, right? Okay. So we got pounds times inches cubed divided by inches cubed. Well, the inches cubed will cancel out, leaving us with what? Double check something here. 1728. Yeah, we're good. Times, so it's 0.283. 0.283 times 2,592. That leaves us 733.536. 733.536. What? Only thing left is pounds, right? And that's what we want. How much does it weigh? Okay. So that's your answer. It weighs 733.536 pounds. Well, you play this section back in the video over and over again. Do the math yourself and enjoy. Enjoy it. It's just simple math. It's no big deal. Let's get that dot out of the way. Now let's go back to this. All right, so here we are. Okay. So a circle, why is it doing that? Oh, it's kicking off the video over here. A circle is not a polygon because it has no straight sides. We're at 37 minutes on this video. It has no straight sides. And we've already talked about when I walked you through the video on the circle and the shapes in the triangle, that the area of a circle is pi r squared, or the area is pi d squared over 4, right? And we already know what pi is. Pi is the relationship. It's the ratio. It's a relationship of the circumference of a circle to the diameter, right? Pi equals c over d. We went through this in the previous video. All right. It's the distance all the way around the circle. It has no units because it's a ratio. So if you want to determine the circumference of a circle and you're given the diameter, just multiply pi times the diameter. You got circumference. Or if you're given the radius, multiply 2 pi radius and you got the circumference. All right? And the formulas are on that other sheet for the circle sheet of how to do the others to find the radius or the diameter. Okay? All right. Now D and R have units. All right? And the circumference has units. All right. So make sure your calculator is not in degrees when we're doing trig. Make sure it is in degree mode. I mean, make sure it's not in radians. Make sure it's in degrees. No radians, degrees. You get a chance, I'll do when we get to trig, we'll do the... Now, the circle, this is your radius and this is your diameter. And you probably remember you were told in this quadrant, x and y is positive, x is negative, y is positive here. X is negative, y is negative down in here. X is positive and y is negative in here. When I show you how to do bolt circles and you use trig, we're going to use absolute coordinating system, and you won't have to worry about the positives and negatives. You just have to read your calculator properly, and we'll have time to go through that. Now, you should have already watched the Khan Academy video on René Descartes, and remember what he said, cogito ergo sum, I think, therefore I am alive, or I am. En français, je puis donc je suis. Little culture there. All right, let's see here. Back to the circle. All right, back to the circle. The area we've already talked about is pi times radius squared. You know how to square things now with your calculator, or the area is pi d squared over 4. Say the radius is 9, then the diameter is 18. So If you want to find the area and you want to use radius, then it's 9 squared times pi, which is 254.469 inches squared. Inches squared, it's area. The area, if you want to use diameter, it's 18 squared times pi divided by 4, which is still 254.469. Go figure, right? It's magic. What can I tell you? All right. Now, by cross multiplying and reducing this stuff out, if you're given the area and you want to find radius, I've made this formula here, algebraic expression. Radius is the square root of a divided by pi. The diameter, if you want to find the diameter from an area, it'd probably be easier just to find the radius and multiply it times 2. But you can do it if you just want to do it this way. 4 times the area divided by pi, and then take the square root of it. All right, the sphere. What's a sphere? A sphere is a three-dimensional circle, right? It's a sphere is a three-dimensional circle. It's like a soccer ball or a tennis ball. All right. The volume of a sphere is pi d cubed over 6, or it's pi. 4 times pi times the radius cubed over 3. Now, I'm not going to show you how to punch these numbers in. You ought to be able to punch these numbers in yourself. Okay, or you can divide 4 by 3 and you come up with 1.333 times pi times the radius cubed, right? I don't know. It depends on how many of these decimals you carry. Will be how accurate your answer is. Me, I would use this formula here or this formula here. And because let's say you round it to 3 decimal places, but your degree of precision may not be that great. So if you're given a volume of a sphere and you want to find the diameter, here's the algebraic rearranged formula. I did that for you. Same with the radius. If you're given the volume of a sphere and you want the radius, there it is. Okay. Or you can do it this way. You really need to have more than 4 decimal places. I would not use this thing. I would not use this. I would stay away from this because it leads you to a least precise output. Okay? So let's say the diameter is 6 inches on a sphere, then the volume of the sphere is what? It's pi times 6 raised to the 3rd power. It's 6 times 6 times 6 divided by 6. Pi times 6 times 6 times 6 divided by 6. The volume is 113.097 blah, 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 inches cubed. Well, what's the weight of this sphere? Now, I'm going to be asking on this a lot. Every one of these is going to have weight to it. So, the volume times the unit weight per volume, right? So let's say the sphere is made out of steel. It's one of these Iron Man spheres or strongman balls or whatever, okay? Then, and it's made out of steel. So we already know what the unit weight per volume for steel in pounds per cubic inch, right? So you take that volume, 113, and multiply it times 0.283. And you end up with 32.065 pounds. 32.065 pounds. Now, we've done this before. Play the video back, stop it, plug in the numbers, see if you don't get that answer. Right circular cylinder. A right circular cylinder. A right circular cylinder. It's like a piece of solid bar stock, right? We call it right because it has a right angle right there, all right? Here's the height, the radius, also has a diameter. Now remember, it's round, so if your formula doesn't have pi in it, you're going to cry. No pi, you cry. All right? So the volume is the area of the base times the height. It's that simple. Area of the base times the height, no matter what the... So the geometric shape of the base is a circle. Yes? The geometric shape of the base is a circle. The geometric shape of the base is a circle. So the area of the circle is pi r squared times the height, right? Or pi d squared over 4 times the height. I don't care how you do it as long as you come up with the right answer, other than cheating, of course. So if you've given the volume of a right circular cylinder, you're trying to find radius, there's the formula, pi, the volume divided by pi times height, take the square root of it. If you're looking for height, then it's volume divided by pi divided by r squared. If you're looking for diameter of a right circular cylinder, you're given the volume. It's 4 times the volume divided by pi, divided by times the height, pi times the height, divided into 4v, and then take the square root of it and the height. There's your formula there. And I've rearranged all this for you so you can, no matter what you're looking for, you should be able to come up with what you're doing there. So let's say that the radius of this cylinder is 6 inches. The height is 12 inches. The diameter is 12 inches, right? If the radius is 6, the diameter bloody well be 12 inches, yeah? So the volume is, and the volume per unit weight per volume, that's the unit weight per volume. So the volume is pi 6 squared times 12. So the volume is 1,357.1680. Oh my God, look at all those decimal places, okay? Inches cubed. So we want to know what the weight is. Again, it's made out of steel. It's 489 pounds a cubic foot, which is 0.283 pounds per cubic inch. So you take this times the volume, and you end up with a solid bar stock of 384 pounds, 384.07 pounds for its weight. Okay? Again, it's volume times unit weight per volume. So, again, this is redundant. We'll be doing this a lot. And you need to know these weights because your machine may not be able to spin something that heavy. How you know you're going to lift that? I doubt you're going to be able to lift 384 pounds. You calculate the raw stock, how much it weighs. You're going to need a robot or a crane to lift it. The right circular cone. Now, what in the name of Zeus is a right circular cone? Well, I should have drew a picture over here. Well, I can draw a picture. A right circular cone. I don't know why I didn't draw a picture on this. Right circular cone. There's the height, goes to the center of the circle. There's the radius, okay, and it has a height. The volume of a right circular cone is 1/3 the area of the base times the height. Now, since it's circular, I think anybody with an IQ above 5 knows that circular means circle, so the area of the base is pi r squared. That's the area of the base. 1/3 is 1/3 times the height. Or it's 1/3 pi d squared over 4 times the height. So let's say the height is 16 inches. The height is 16 inches. The base is 6 inches in diameter, okay? Diameter is 6 inches, or the radius is 3. So you got 3 ways of doing this. 1/3 pi times the radius squared times 16, or 1/3 pi times the diameter squared divided by 4 times 16. And guess what? N-E-M. Oh my God. We get the same answer, 150.796 inches cubed. 150.79644 inches cubed. It's the same stuff, right? How much does it weigh? Well, I don't know, Mr. Wizard. What's it made out of? Well, let's say it's made out of steel. Okay, again, the unit weight per volume of steel is 489 pounds. 489 pounds, pounds, foot cubed, which equals, we're going to say 0.283 just for argument purposes, pounds per cubic inch, because we divide 489 by 1728 and we round it, go away. And we round it. So we're going to take 0.283 times our volume, 0.283 pounds per inch cubed times our volume of 150.79964 cubic inches. Cubic inches will drop out, leaving us with pounds. I showed you how to do that before. 0.283 times 150.79644 or 45, depending on how many decimals you carry out. So we get 42.6753 pounds. We get 46 point, what did I say, 6753? You do the math, you check me. 53. Send me a nasty email if I screwed up. Pounds is what it weighs. Now that's going to end this part of this video, and we're going to start part 2 right here on solids, space, and negative space. Solid space and negative space. And I am going to shut off the internet for the next video. This is annoying. So part 2 starts at solid space and negative space. We will talk about the mystery of the donut hole and such as that. So that ends this video, and we're running up on 50 minutes, which is a long video for YouTube to eat. I'll see you on part 2.